Good morning, chemistry. This is Mr. Moore. This is the first video in a series of 3 for this week. This week, the worksheets that you see below correspond directly with the videos. I would highly recommend that you have the worksheet open while we're doing the video. You should take notes while you're watching this video, but you should also have the homework with you. The 3 videos correspond directly with worksheet 1, 2, and 3, even though it's all one document. So you should watch video 1 and then do worksheet 1, then watch video 2, then do worksheet 2, and so on. This week, our main goal is simply to learn how to write and name simple chemical formulas. We're going to learn how to write and name ionic formulas and molecular formulas. We will learn how to write and name acids and bases, but later on in the year. So first, a quick review. If you remember a couple of weeks ago, we referred to the periodic table and we talked about valence electrons. And we talked about how valence electrons are the outermost electrons in an atom. Since these are the electrons that interact when an atom comes in contact with another atom, these valence electrons dictate how an atom is going to act. Now, how many valence electrons an atom has corresponds directly with the group number that it's in. For example, group 1 that we learned where the alkali metals have 1 valence electron. Group 2 has 2, group 3 has 3, group 4 has 4, and so on, all the way up to group 8. We also learned that all atoms want to have 8 valence electrons. So all of the atoms on the periodic table are trying to react with other atoms to get that stable 8 valence electrons. Only exceptions to that are hydrogen and helium, who only need 2. When we look at the periodic table, if you remember, we divided it between metals and nonmetals by using this dividing line right here. This dividing line gave us metals over here on the left and nonmetals over here on the right. Whenever a nonmetal bonds with a metal, we have a situation where one atom wants to give up electrons and another atom wants to take electrons. And as a result of that, we get something called an ion. And if you remember from past lessons, an ion is when an atom gains or loses an electron. And since we can't change the number of protons, that creates an atom that has a positive or negative charge. If it loses electrons, then it becomes positive. If it gains electrons, then it becomes negative. So an atom that loses 1 electron becomes positive 1. An atom that loses 2 electrons becomes positive 2. An atom that gains 1 electron becomes negative 1, and so on. Then what we did is we went to the periodic table and we said, okay, if group 1 only has 1 valence electron, then that means that all of group 1 is going to want to lose 1 electron when it bonds with other atoms. So all of group 1 would form a +1 cation or a +1 ion. So on all your periodic tables, you should have this big +1 at the top. And if you don't, put it up there now because you're going to need it. Group 2, same thing. You have 2 valence electrons. So these atoms, when they bond with others, want to give up 2 electrons. So all of these atoms should form +2 ions. All of these group 3 atoms want to give up 3, so they form +3. Now, these nonmetals want to gain electrons. Group 5, where nitrogen is, they want to gain 3 to get 8, so they will form -3. Group 6, that has oxygen at the top, all of them form -2, and then group 7 are all -1. This -1 that you wrote on top corresponds with all of these atoms. This -2 corresponds to all of these, and so on. The guys in the middle, we're going to talk about in video number 2, so we're going to ignore them for now. What we're going to talk about in this video is what happens when something from one of these 3 groups bonds with something from one of these 3 groups. Okay? And what we call that is an ionic bond. When we have an ionic bond that is a metal with a nonmetal, that is only two elements, we call that binary. Bi meaning two, bi meaning two. So if you have a binary ionic compound, the name just simply always has an IDE at the end. For example, let's look at these examples. CaCl2. CaCl2 is a metal and a nonmetal. When we have a metal and nonmetal, we know it's ionic. So how we name it is we name the metal, which is calcium, and then we name the nonmetal with an IDE at the end. And that's how you name it. If you look at this, this is binary and ionic. It's two elements, and it's a metal and a nonmetal. So we name the metal, and we name the nonmetal with an IDE at the end. This is calcium chloride. This is sodium fluoride. Here's another example. BeO. This is binary. It's two elements. It's ionic because it's a metal and a nonmetal. So I have to add IDE at the end. Be is beryllium. And oxygen gets turned to oxide. Last example for this, Li2O. This is binary, and it is ionic, metal with a nonmetal. So I know I have to add IDE at the end. Li is lithium. O is oxygen, so I turn that to oxide. Simple as that. The harder part with binary ionic is writing the formulas. When we write the formulas, we have to pay close attention to the charges. Now, before we do that, let's make sure we understand what a subscript is. When I write a formula like water, H2O, this little number right here is called a subscript. What that means is that when we have this molecule, it has one oxygen and two hydrogens, H2O. Whenever we write a formula, this subscript tells us how many of each atom in that compound that we have. A coefficient is a big number that goes in front like this. A coefficient doesn't do anything at all to the structure of the molecule. It just tells us how much of it we have. This just means we have two waters. If I write H2O2, if I change one little subscript, that changes it entirely. H2O2 is hydrogen peroxide, which would bleach your hair or kill you if you drink it, whereas H2O is H2O. So what we want to do is be able to write a formula that's correct with the correct subscripts. For example, if I say to you, we want to write the formula for sodium chloride. As soon as you see that IDE, you know that it is ionic, and you know that it has two elements. Sodium is Na, and chloride is chlorine. So right away, you know what the two elements are supposed to be. What you don't know are what the subscripts are supposed to be. To do that, you have to go back to your periodic table. If you look at your periodic table, we must know what's called the charges. Remember, when we look at this, we see Na is in group 1, and in group 1 forms a +1 ion. And remember what that means. That means that Na wants to give up one electron. So when you write the formulas, you always put a big +1 over top of that, because it's sodium. Chlorine, if you look back at your periodic table, forms a -1. It's in group 7, forms a -1. So you're going to put a -1 over top the chlorine. And what the rule is that these charges must always equal 0. If they don't equal 0, then we have to make sure that we use subscripts to balance out the formula. +1 and -1 equal 0. So if you put the charges up and it equals 0, then you leave it alone. So the formula for sodium chloride is NaCl, and you're done. Now, what if I asked you to do, let's say, sodium oxide instead of chloride? Okay? Again, you know it's binary because of the IDE, and you know it's a metal and a nonmetal. So for the sodium, you write down Na, and then for oxide, you know it's oxygen, so you write O. The second step, as we talked about, is to put the charges up. And if you look at Na, it's in group 1, so we put a +1 over top of it. And we look over at oxygen. Oxygen is in group 6, and it has a -2. So we put a -2 over top of it. The rule is very simple. It must equal 0. +1 and -2 don't equal 0. If the charges don't balance, you do what's called crisscrossing. You take the number and you simply crisscross it down to the other element. This number goes down here, and that number goes down here. So the formula is going to be Na2O. This 2 is there because I brought this 2 down. I crisscrossed. We don't write ones. Just writing the O is sufficient. So the formula for sodium oxide is Na2O. What if I asked you to do calcium oxide? Calcium oxide. Calcium is Ca. Oxide is oxygen. You look on your periodic table, and calcium is in group 2, so we put a +2 on top. Oxygen is in group 6 with a -2 on top, so we put a -2. Do those charges balance? And the answer is yes, so we leave it alone. The formula is CaO. Done. What if I asked you to write the formula for, let's say, aluminum? Let's do this example. Let's do aluminum sulfide. This is binary because of the IDE, and it's ionic because of the metal and the nonmetal. The aluminum is Al. Sulfide is from sulfur, which is S. You look on your periodic table, and aluminum is in group 3, so it's a +3, and sulfur is in group 6, so it's a -2. You put those charges at the top. Aluminum is a +3, sulfur is a -2. Those definitely do not balance, so we crisscross. And we bring the 2 down here as a subscript, and we bring the 3 down here as a subscript. And our formula will be Al2S3. I'll do one more example. Let's try cesium nitride. Cesium is Ce, and it's in group, it's going to be in group cesium is CS, sorry, I messed up. CS, and that's in group 1, and nitride is nitrogen, and that's in group 5. So cesium is a +1 and nitrogen is a -3. Those do not balance out, so we crisscross. This goes down here, that goes down here. So our formula is CS3N. And there you go. So that's how you would both name a binary ionic formula and how you would write a binary ionic formula. If you would like to rewatch this video to do some of your practice problems, you may. Otherwise, please go and do homework sheet number 1.